morning dear students of class 7. I welcome you all to the second video class of chapter number 13, that is Exponents and Powers. Today before starting this class we will do some questions of exercise 13.1. Taking question number 4 part 4. This says that identify the greater number and the numbers are 100 to the power 2 or 2 to the power 100. So it's very easy to find 100 to the power 2. What we will do is we will multiply 100 how many times? 2 times, and the number we got is 10,000, right? But how do we find 2 to the power 100? It is a very large calculation. So what we will do is we know that a to the power b is greater than b to the power a only when b is greater than a. Means if we have to compare two numbers of form a to the power b and b to the power a, okay, which number would be greater? The number having power highest. Means b is greater than a, so a to the power b will be greater than b to the power a. Okay. Now check this number. Here a is equal to 100 and b is equal to 2, and we are comparing 100 to the power 2 with 2 to the power 100. So which number will be greater? 2 to the power 100 will be greater because the power of 2 is highest. Here the power of 100 is 2. So which is greater? 2 to the power 100. So we can say without calculating that 2 to the power 100 is greater than 100 to the power 2. Right? So write it. Okay. There is an exception case. Suppose we have to compare 2 to the power 3 and 3 to the power 2. Okay. So we know that the number having highest power would be greater, but in this case 2 to the power 3 means 2 into 2 into 2. Okay. The value comes to be 8, and 3 to the power 2 means 3 into 3, which is 9. So as we can see, 9 is greater than 8 and 3 to the power 2 will be greater than 2 to the power 3. Except this case, this rule is valid everywhere. Now moving to question number 8, part 1. In this question we have to compare 2.7 into 10 to the power 12 with 1.5 into 10 to the power 8. Okay, so 2.7 into 10 to the power 12 can be written as 27 by 10 into 10 to the power 12. Now the denominator 10 will cancel out one of the numerator 10. Okay, and this will become as 27 into 10 to the power 11. Right? And 1.5 into 10 to the power 8 can be written as 15 by 10 into 10 to the power 8. Now here the denominator 10 will cancel out one of the 10 of 10 to the power 8, and it will become 15 into 10 to the power 7. Now it is easier to compare 27 into 10 to the power 11 with 15 into 10 to the power 7, because this number is having larger number of zeros, so this will be greater than this one. Okay, so 27 into 10 to the power 11 is greater than 15 into 10 to the power 7, or we can say it as 2.7 into 10 to the power 12 is greater than 1.5 into 10 to the power 8. Okay. Now let's move ahead towards our class. In this class we are going to understand the laws of exponents. The first law is multiplying powers of same base. Means 8 to the power n into 8 to the power n. Here the base of these two numbers are same, but the power are different. Then it will become a to the power m plus n, means two numbers having same base but different powers will be written as, the base will remain as it is and the powers will get added. Okay. Now let's have an example. 2 to the power 3 into 2 to the power 2. We can solve it as 2 to the power 3 means 8 into 2 to the power 2 is 4. 8 into 4 becomes 32. And this can also be solved using the first law, which says that numbers having same bases but different powers can be written as base remains as it is and the powers get added. Okay. So 2 to the power 3 plus 2. 3 plus 2 means 5. So the number becomes 2 to the power 5. And the value of 2 to the power 5 is also 32 because 2 into 2 into 2 into 2 into 2 is what? 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 16 and 16 into 2 is also 32. So this is our answer. Okay. So as we can see that using the laws of exponent, the calculation becomes easier. Now moving towards second law, which is dividing powers of same base. Means if a number is of form a to the power m and it is being divided with another number of form a to the power m, it becomes as a to the power m minus n. So as we can see, these two numbers are having same base but their power are different, and since they are getting divided, so the final answer will become the base remains as it is and the powers get subtracted. An example for this: 3 to the power 7 divided by 3 to the power 4. Okay. So if we are going to calculate 3 to the power 7 and 3 to the power 4, then divide, then it becomes very large calculation. So we will directly use the second law of exponent and solve it. So 3 to the power 7 divided by 3 to the power 4 will become, base remains as it is and the power get subtracted. So 7 minus 4. Answer comes out to be 3 to the power 3. Okay. Moving to third law of exponent, taking power of power means any number of form a to the power m to the power m can be written as a to the power m into m. It means that any number of form a to the power m having another power m, so the powers in the answer gets multiplied and the base remains as it is. Okay. Taking an example, 6 to the power 4 to the power 2 means here the base is 6 and its power is 4 and the whole power is 2. Okay. So we can do this by multiplying the powers 4 into 2 and it becomes 6 to the power 8 as our answer. So it is clear, if the power is having another power, then the powers get multiplied and the base remains as it is. Okay. Moving to fourth law, which says multiplying power with same exponents, means here the base is different and the power is same. Here the numbers are a to the power m into b to the power m, means the numbers are having different bases but the power is same. So the answer for this will be a into b to the power. Taking an example, 2 to the power 5 into 3 to the power 5. As we can see that the base number are different but the powers are same. So we will apply this fourth law in this particular question and solve it. So it will become as 2 into 3 to the power 5 because powers is same. So the number becomes 2 into 3 is 6 and 6 to the power 5 is our answer. Moving to fifth law, which says dividing power with the same exponent means a to the power m divided by b to the power m. Here the base number are different but their power is same. So it can be written as a divided by b to the whole power m. Okay. So if the power are same and the base number are different, we will directly divide the base numbers and the power will remain as it is. In an example, 8 to the power 4 divided by 2 to the power 4. Okay. So we can see that the base numbers over here are different but their power is same. It can also be written as 8 to the power 4 divided by 2 to the power 4. So what we will do is we will divide the base numbers and the power will remain as it is. Okay. So 8 divided by 2 to the power 4. 8 divided by 2 will be 4 to the power 4 and this is our answer. Now moving to sixth law, which says that number of exponent 0. Suppose a number is having exponent 0 or power 0, a to the power 0, then it will be 1. Okay. Any number having power 0 will be 1. For example, 2 to the power 0 is none other than 1. Or 5 to the power 0 is also 1. So any number we will write in the base and if the power is 0, the number will be 1. Students, now you are in a position to do exercise 13.2. Try to attempt question number 1. Rest of the questions I will discuss with you in the next class. Okay? Thank you.